All right, everybody, welcome back to Physics with Arif. This is Unit 2.08. It's friction. Yes, we're learning about friction. But what is friction? Yeah, this is it. Friction is the force that tries to stop materials from sliding across each other. Friction is everywhere. When you rub your hands, when you drag your feet on the ground, when you make babies, and even when sliding across ice. A few more examples is, for example, when you're writing with a pencil, the lead, it slides across the paper pretty easily, but there is still some friction on there. Or another example is when you're walking, pushing a skateboard, riding a bicycle, riding a car. Basically, it's literally everywhere. Even when you breathe, there's friction. Alright, there's two kinds of friction. Static friction. First, we'll cover static friction. Static friction is friction when the downward force is greater than the pulling force. For example, when you try to push the sofa, or you're too weak, so it does not move. Do you even lift, bruh? Anyways, so yeah, static force is when gravity is stronger than the actual pushing force. Like when you're trying to push this sofa, for example, it's too heavy, or maybe you're just too weak. The other kind of friction is dynamic friction. It's when the force, downward force, is weaker than the pulling force, making it move. For example, when you ask me to help you move your sofa because you're too weak. So as you can see, I move your sofa pretty easily because you're weak, not the sofa too heavy. Alright. Things to clarify. Some people get this wrong, particularly children or idiots. Ice has friction. Even though you might think otherwise, it just has low friction. This is why sometimes when you grip ice, it will slip out of your hand. There is friction, it's just really small, and it's quite slippery and shit. Alright. Tires have rubber wheels, so that when you can grip the road and push the car moving forward. If you don't have enough grip on the tire, it will burn and slip out, like that picture right there. However, the bearing where the wheels are mounted must have low friction, because with high friction, the wheels cannot rotate. So, there you go. Cars, they use two friction methods. They use low friction at the bearings, and they use high friction at the tires so they can push the car forward. It's quite common to see things like this. For example, at bicycles. When you're riding a bicycle, you need the tire to be lots of friction so you can push forward. But you need as little friction as possible at the chains, because you want the chains to move very fluently and not, dragged on each other. And also, you'd want lots of friction on the brake pads, because if you have very little friction on the brake pads, you will most likely die or, go to a hospital. Alright. Here's something interesting. Something you might not think about is air. Air, yes, even air has friction. We have a special name for this, which is air resistance. This is the reason that when dust particles enter Earth's atmosphere, it burns up. The friction in the air creates heat, and too much will disintegrate the dust particles. This is what basically meteor showers or shooting stars are in the night sky. It's just dust particles entering Earth's atmosphere, lighting up, and then burning out. They disintegrate. The heat is too much. Also, another example of air resistance friction is the ones that we have talked about is when you're falling down, free fall, and then you hit terminal velocity. That is air resistance. Or when you're driving a car and you're actually supposed to go way faster, but you slow down because of air resistance. Or, you know, even, yeah, when you're parachuting, you have air resistance. Air resistance is everywhere. When you're moving your arm around, there's air resistance. You just don't feel it because you're too strong. Alright, that's it. I'm done. 5 minutes. Goodbye.